Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am your host, Dr. Nasir Rahman, Assistant Professor, HOD, Department of Mathematics, Allama Iqbal Open University, Islamabad. We have prepared a brand new series of programs for the course Business Mathematics with course code 5405 and 1429. Today you will listen the 15th program of the series, which is about unit number 9. And in this program, we will discuss and learn about these topics. First, derivative test. Second, derivative test. Curve sketching. Revenue, cost and profit applications in business. Dear students, first of all, we start from first derivative test. First step is to find all critical values x star. Determine the value of f prime of x to the left, denoted by xl, and to the right, denoted by xr, of the point x star. So we have the following cases. Number A. If f prime of xl is positive and f prime of xr is negative, then there is a relative maximum for f at the point x star, and it is f of x star. Second case is if f prime of xl is negative and f prime of xr is positive, then there is a relative minimum for the function f at the point x star, and it is f of x star. The third case is if f prime of x has the same sign at both xl and xr, then an inflection point exists at the point x star. Dear students, now we define second derivative test. Find all the critical values x star such that f prime of x star is equal to 0. Determine the value of f double prime x star for any critical value x star. Then we have the following cases. Case A. If f double prime x star is positive, then there is a relative minimum for f at the point x star. Second case, if f double prime x star is negative, then there is a relative minimum for f at the point x star. The third case, if f double prime x star is equal to 0, then no conclusion can be drawn at the point x star. Dear students, key data points. To determine the general shape of the graph of a function, the following attributes are most significant: relative maxima and minima, inflection points, x and y intercepts, ultimate direction. Dear students, now we look at an example. Sketch the graph of the function f of x is equal to x cube over 3 minus 4x square plus 12x plus 5. First of all, we calculate the relative maxima and minima. To find the relative extrema of the function f of x, first we calculate the first derivative, that is f prime of x is given by x square minus 8x plus 12. Now putting f prime equal to 0, we get x square minus 8x plus 12 is equal to 0. Now we factorize it and we get x minus 2 multiplied by x minus 6 is equal to 0. Now we solve it and we get that the critical values are x is equal to 2 and x is equal to 6. Now we substitute these critical values in the given function f of x. Dear students, at the point x is equal to 2, we get f of 2, which is given by 2 cube over 3 minus 4 into 2 square plus 12 times 2 plus 5. That is, we get f of 2 is equal to 15.66. Similarly, at the point x is equal to 6, we get f of 6 is equal to 6 cube over 3 minus 4 into 6 square plus 12 times 6 plus 5. That is, we get f of 6 is equal to 5. Hence, the critical points exist at the point 2, 15.66 and 6, 5. Graphically, all these points have zero slope and we have that the zero slope condition exists. The second derivative of f is given by f double prime of x, and it is equal to 2x minus 8. Now we test the nature of critical point 2 and 15.66 by substituting x is equal to 2 in the second derivative of f. So we get f double prime of 2 is equal to 2 into 2 minus 8, that is equal to minus 4, which is negative. Therefore, a relative maximum occurs at the point 2. Now we test the nature of critical point 6, 5 by substituting x is equal to 6 in the second derivative of f, that is f double prime of 6, which is equal to 2 into 6 minus 8, which is equal to 4, which is positive. Therefore, a relative minimum occurs at the point 6, 5. Dear students, now our second point is inflection points. To find inflection point, we take second order partial derivative equal to 0. That is 2x minus 8 is equal to 0. That is x is equal to 4. Dear students, now substituting x is equal to 4 into the function f, we get that f of 4 is equal to 4 cube over 3 minus 4 into 4 square plus 12 into 4 plus 5. That is, we get f of 4 is equal to 10.33. Hence, the inflection point occurs at 4, 10.33. Dear students, the third point is intercepts. So first we calculate the y-intercept. The y-intercept usually is an easy point to locate in this case, and it is given by putting x is equal to 0 in the given function. We get f of 0 is equal to 5. Therefore, the y-intercept occurs at the point 0, 5. The next step is the ultimate direction. In the given function f, the highest power term is x cube over 3. To determine the behavior of x more and more positive, we need to observe the behavior of x cube over 3 as x become more and more positive. So as x goes to plus infinity, x cube over 3 also goes to plus infinity. Therefore, as x goes to infinity, f of x, which is given by x cube over 3 minus 4x square plus 12x plus 5, also goes to plus infinity. Similarly, if x goes to minus infinity, x cube over 3 also goes to minus infinity, and therefore our function f of x goes to minus infinity. Dear students, now we try to sketch the given function and we draw its graph. The final sketch of the given function is given by, dear student, you can see on the x-axis we have x, and on the y-axis we have taken f of x. So you can see when x is equal to 2, y is 15.66. When x is equal to 4, y is 10.33. When x is equal to 6, y is 5. Now locating these 3 points, and when x goes to minus infinity, you can see the arrow going downwards. So also f of x goes to minus infinity. Similarly, when x goes to plus infinity, you can see the up arrow which is going to plus infinity. Dear students, now we define the revenue function. Revenue is the total payment received from selling a good or performing a service. The revenue function is denoted by R of x, and it reflects the revenue from selling x amount of output items at the price P per item. Therefore, we can write the total revenue is equal to price per unit multiplied by the quantity sold. Example: a firm has determined that total revenue is a function of the price charged for its product. Specifically, the total revenue function is R, which is denoted by f of p, and it is given by minus 10p square plus 1750p, where p equals the price in dollars. The question is, number 1, determine the price p, which results in maximum total revenue, and second thing, what is the maximum value for total revenue? Dear students, firstly we will calculate the first derivative of the revenue function, that is we calculate f prime of p, and it is given by minus 20p plus 1750. Now we set f prime of p equal to 0. So we get minus 20p plus 1750 equal to 0. That is p is equal to 87.5. Dear students, hence the relative maximum occurs at the point 87.5. We can verify this by using the second derivative test. That is, we calculate the second derivative of f with respect to p, that is f double prime of p, and it is equal to minus 20, which is negative. Therefore, at the point 87.5, f double prime 87.5 is minus 20, which is negative. Therefore, a relative maximum value of the function f occurs at the point p, which is equal to 87.5. Now, the maximum value of r is found by substituting p is equal to 87.5 into the given function f. That is, f of 87.5 is equal to minus 10 into 87.5 square plus 1750 times 87.5. So we get f of 87.5 is equal to 76,562.5. Dear students, therefore, we can say that the total revenue is expected to be maximized at $76,562.5 when the firm charges $87.5 per unit. Dear students, you can also see the graphical representation of the given function in this graph. On the x-axis, we are taking the price, which is in dollars, and on the y-axis, we are taking the revenue. Therefore, you can see that when the price is 87.5, the revenue is 76,562.5, which is denoted by the dotted lines. And when the price exceeds this value, you can see the graph going downward. Similarly, if you see the price before 87.5, the graph is also going downward. So our conclusion is the maximum revenue will be at the point 87.5. Dear students, now we define cost. Cost is the total cost of producing output. The cost function consists of two different types of cost. First one, variable costs. Second one, fixed costs. First of all, we define variable cost. It varies with output, the number of units produced. The total variable cost can be expressed as the product of variable cost per unit and the number of units produced. If more units are produced, the cost is more, and correspondingly, if less items are produced, the cost will be less. Second thing is fixed cost. Normally, it does not vary with output. In general, these costs must be incurred whether the items are produced or not. So, we have the general formula for the cost function, and it is given by C of x, and it is equal to F plus V of x. F represents the fixed cost, V represents the variable cost. Therefore, total cost is equal to fixed cost plus variable cost. Dear students, now we look at an example. The total cost of producing Q units of a certain product is described by the function C, given by C is equal to 1 million plus 1500 Q plus 0.2 Q square, where C is the total cost stated in dollars. Determine the number of units of Q that should be produced in order to minimize the average cost per unit. Dear students, first of all, we calculate the average cost. The average cost per unit is denoted by C bar, and it is calculated by dividing the total cost by the number of units produced. That is, C bar is equal to F of Q, and it is given by C divided by Q. So we divide the C function by Q, and we get 1 million divided by Q plus 1500 plus 0.2 Q. Now we take the first derivative of the average cost function, and it is given by F prime of Q, and it is equal to minus 1 million Q raised power minus 2 plus 0.2. Now we set the first derivative f prime of q equal to 0. So we get minus 1 million q raised power minus 2 plus 0.2 is equal to 0. After simplifications, we get q square is equal to 5 lakh. Since q is the number of units, so we round it. That is, we get q is equal to plus minus 707 units. Since the production must be positive, so we only take the positive value. Therefore, q is equal to minus 707 is meaningless for us. Now we test the nature of critical points by taking the second partial derivative, that is, we calculate f double prime q. So which is equal to 2 million divided by q cube. Now we put q is equal to 707. So we get f double prime 707, which is given by 0.00056, which is positive. Dear student, the second derivative is positive, which means that the minimum value of f occurs when we take q is equal to 707. Therefore, the minimum average cost per unit is f of 707. So we calculate by putting q is equal to 707. So we get 1 million divided by 707 plus 1500 plus 0.2 multiplied by 707. After simplifications, we get that f of 707 is equal to $1,782.82. Dear students, now you can see this on the graph. By sketching the average cost function, we get the following graph. On the x-axis, we have taken number of units produced, which is denoted by q, and on the y-axis, we have denoted average cost per unit, which is also in dollars. So you can see that when q is equal to 707.11, you get y is equal to 1782.84, and it is minimum. All other values of average cost per unit are greater than or equal to this value. Therefore, we conclude that the cost will be minimized. So when we produced 707 units. Dear students, now we define profit function. The profit function P of x is the difference between the revenue function R of x and the total cost function C of x. So profit function is equal to revenue minus cost. So we write P of x is equal to R of x minus C of x. Marginal approach to profit maximization. Dear students, given a level of output Q star where R prime of Q is equal to C prime of Q, producing Q prime will result in profit maximization if the second order partial derivative of the revenue function is less than the second order partial derivative of the cost function. Dear students, now we see an example for the profit maximization and getting the maximum profit. The total cost and total revenue functions for a product are given by C of Q is equal to 500 plus 100Q plus 0.5 Q square. R of Q is 500Q. First question is, using the marginal approach, determine the profit maximizing level of output. And the second question is, what will be the maximum profit? Dear students, the profit function using the equation is given by P of Q, which is equal to R of Q minus C of Q. Differentiating the above equation, we get P prime of Q is equal to R prime of Q minus C prime of Q. Now we putting the first derivative of the profit function equal to 0 and solving it for Q, we get R prime of Q is equal to C prime of Q. Let Q star be the value where R prime of Q is equal to C prime of Q. Now the second partial derivative of P is given by P double prime of Q, and it is given by R double prime of Q minus C double prime of Q. By the second partial derivatives, we know that the profit will be maximized at the point Q is equal to Q star, provided that the second order partial derivative of P at that point, that is P double prime at Q star, will be less than 0. That is, R double prime of Q star minus C double prime of Q star must be negative. So taking second order partial derivative of C on the other side, we get that R double prime at Q star is less than C double prime at Q star. firstly we differentiate the given equations C and R with respect to Q, that is C prime of Q is equal to 100 plus Q and R prime of Q is equal to 500. Therefore, putting them equal, we get C prime of Q is equal to R prime of Q. Dear students, equating the first order derivatives, we get 100 plus Q is equal to 500, that is Q will be 400. Now taking again the second derivatives, we get C prime of Q and R prime of Q, we get C double prime of Q is equal to 1 and R double prime of Q is equal to 0. Since R double prime of Q is 0 and C double prime of Q is 1, so we get R double prime of Q star is less than C double prime of Q star, that is given by 0 less than 1. Therefore, there is a relative maximum on the profit function when we take Q is equal to 400. Dear students, the maximum profit is given by P is equal to F of Q, which is the revenue function minus cost function, and it is given by R of Q minus C of Q. So P is equal to 500Q minus 500 minus 100Q minus 0.5Q square. So after simplification, we get P is equal to 400Q minus 0.5Q square minus 500. Now we put Q is equal to 400 in the profit function and we get profit function equal to 400 multiplied by 400 minus 0.5 times 400 square minus 500, and after simplifications we get P is equal to 79,500. Hence, we conclude that the maximum profit will be 79,500. Dear students, that's all for today's program. We hope that now you would definitely have a better understanding of these topics. Next time we will come to you with a new program. For suggestions, questions and queries about this program, you are more than welcome to contact Department of Mathematics, situated at block number 7, Allama Iqbal Open University, Main Campus, Islamabad. You can also contact us at 051 905 7191. Till then, goodbye and Allah Hafiz.